Hello and welcome to this lesson on fermentation. In today's lesson, we will firstly understand the concept of fermentation as a metabolic process by which microorganisms convert sugars into alcohol and carbon dioxide. We will also explore how aqueous solutions of ethanol are produced through the fermentation process and discuss the practical applications of this process. So far, we've covered the general properties of alcohols, including their chemical structure and physical properties such as boiling points and solubility. You've also learned about their importance and uses in everyday life. Building on this foundation, today's lesson will deepen our chemical understanding by exploring how these alcohol compounds are produced through the biological process of fermentation. This will not only enhance your knowledge of organic chemistry, but also show how chemistry is applied in real-world processes like food and beverage production. Let's get started. Fermentation is an anaerobic process in which microorganisms like yeast convert sugars into ethanol and carbon dioxide. Anaerobic here means that this all occurs in the absence of oxygen. During fermentation, the chemical process can be described with the following equation. Glucose makes ethanol plus carbon dioxide. This shows that one molecule of glucose is broken down into 2 molecules of ethanol and 2 molecules of carbon dioxide. Yeast enzymes such as zymus facilitate this reaction and speed it up. These enzymes help to break down the large sugar molecules into simpler molecules that the microorganisms can then convert into alcohol and carbon dioxide. Fermentation occurs in an aqueous environment, which means it's carried out in water or a water-based solution. This is done because it allows the sugar to dissolve, making it accessible for yeast to metabolize efficiently, and because it allows the yeast to move around freely and come into contact with sugar molecules more easily. After the reaction, ethanol remains dissolved in the water, while carbon dioxide escapes as gas. This gas can be observed as bubbles in the solution, indicating active fermentation. The resulting solution after fermentation contains ethanol dissolved in water, along with other fermentation byproducts and any residual sugars that were not consumed by the yeast. The concentration of ethanol can vary depending on the amount of sugar available and the efficiency of the fermentation process. The aqueous ethanol solution can then be separated using distillation to extract the ethanol. Fermentation is not just a laboratory phenomenon. It has significant real-world applications such as making alcohol, making bread, and making biofuel. Here's what happens in each. Fermentation is key to producing alcoholic beverages like beer, wine, and spirits. Yeast breaks down sugars in grains or grapes to produce ethanol and carbon dioxide. In bread making, yeast ferments the sugar in dough, producing carbon dioxide gas. This gas gets trapped in the dough, causing it to rise and giving the bread its light and fluffy texture. Finally, we have biofuel. Ethanol, produced through fermentation, is also used as a biofuel, providing an alternative energy source to fossil fuels. By grasping these fundamental concepts, you not only understand how fermentation works, but also appreciate its significance in various industries and everyday products. This understanding bridges the gap between theoretical chemistry and practical applications, showing how science directly impacts our lives. In today's lesson, we delved into the concept of fermentation as a metabolic process where microorganisms like yeast convert sugars into alcohol and carbon dioxide. This process is facilitated by enzymes, which act as biological catalysts. We discussed how this process takes place in an aqueous environment, where yeast cells are suspended in water, allowing them to interact with dissolved sugars. As the yeast consumes the sugars, ethanol is produced and remains dissolved in the water, forming an aqueous ethanol solution, while carbon dioxide is released as gas bubbles. This lesson highlighted the remarkable biological process that allows yeast to convert sugars into ethanol and carbon dioxide, a fundamental mechanism with significant applications in industries like baking, winemaking, and biofuel production. Watch the rest of the GCSE chemistry course at Sophos Education.